So for correlation, okay, there is a R value which comes, which is called as Pearson coefficient value. If it is, so it ranges between 0 to 1. If it is 0.121, it's a positive correlation. If it is near to 0, it is no correlation. If it's less than 0 or in negative, like minus 0.8, minus 0.9, something of that sort, and it's a negative correlation. And we all know the significance of positive negative correlation. Positive is both the variables are moving in the same direction. If one increases, another increases. Okay, if one decreases, another decreases. Okay, no correlation is, we know that there is nothing need to work upon it. And negative correlation is if one increases, another decreases. Okay, so my scenario is I'm doing a project on improving the average handling time, and we all know the lesser the average handling time, the better it is. I have another variable which is hold time. Okay, I have a R value which has come as 0.89. Okay, now what would be my strategy here?
Okay,
What,
so
okay, just yeah, go ahead.
so because it's a positive correlation, which means that out of whole time and AHT, which is X and which is Y, I mean, which is the one we are
Why isn't, so why isn't HT? I'm doing a project on improving the
okay,
HT.
improving AHT. Okay, okay, fine. So your whole time, if it is if it will increase, your average handling time will also increase.
So for this particular variable, which is hold time, should I be working on it? Should I be ignoring it?
Yes,
What should I be doing?
yes, because if you have to improve your average handling time and it is dependent on hold time, that is what the R value says. That means you have to work on X, because if you will improve X, that is the whole time, you will as result AHT will be improved.
Absolutely. So if I am able to improve my hold time, because a law says कि अगर आप अपना होल्ड टाइम रिड्यूस कर लोगे तो आपकी एचटी अपने आप रिड्यूस हो जाएगी, ठीक है? And that's what my R value says, which is very very near to 1. Okay, but it's a positive. So now if it's a positive correlation, it says I would work on the hold time as a cost to improve my HT. So if I manage to reduce my hold time, my HT will also decrease. But if I have not worked on it, if my hold time increases, my HT will also increase or decrease?
Increase.
Increase.
Increase. Absolutely, absolutely. That's what I want everybody to understand, that it all depends on the R value, what sort of a decision that you will be taking. Earlier example that we took, wherein the R value was very very near to 0 but was in negative. Okay, now Rahul, I'll give you a scenario. Now you can answer this. If R value is minus 0.6, what would you do in this case? Let's hear it from you. Just take 30 seconds, 20 seconds, whatever time you want to take, and answer this question. This question is for all, but I want Rahul to answer this.
Okay. So if it's minus 0.6, that means there is a negative correlation and they both are not that closely related, or probably I would say not related at all, right? So in here,
Yes.
we would not, that means the whole time is not impacting my average handling time.
It's negative.
It's strong negative correlation.
It's a strong negative correlation.
Yeah.
So which means two variables have no relation. Okay. If you think in a layman terminology, if there are two people, okay, who have a very negative correlation, very negative sort of correlation, both are opposites to each other. Okay, will you make them work together? Will you think if we work on this one, the other would increase? No. Okay. Similar in case of a practical situation also. If my R value is a strong positive or probably greater than 0.3 or more than that, it becomes a stronger chance to work on this. So that's what my correlation tells me. Scatter plot did not tell me significantly. It just tell me the slope of the graph, whether it's a positive or negative. It does not give me any decision sort of a criteria. But yes, let me go back to the Minitab here. Okay. So this does not give me the any graphically. So when you do a correlation, please do a scatter plot along with that. Why? Because scatter plot will give you a graphical representation. Correlation is not giving you a graphical, it's only giving you a decision criteria. So while doing your project, when you're making any presentation, when you want to show any correlation, use a scatter plot for the visual management and use a correlation for the statistical inference to conclude the variable, the relation between two different variables. Okay.
So Simar,
Now,
just I'm so sorry. Just a question here. If my
yeah, yeah.
both the variables, say if I'm considering AHT as one of the variable, and then the second variable I'm considering is the sales in dollars,
Yeah.
and here if I see a negative correlation, in
Hmm.
that scenario I will still go ahead with that X, because it actually means that lower the AHT, higher is
Absolutely. Yes. Yes.
yeah yeah
It all depends upon the scenario.
yeah
It
yeah.
all logical. It's all common sense. Okay. That's why I emphasize on the hold, because the lesser it is, the better it is for us.
Yeah.
It is not always that I look at the uh, R value. It look at the different sort of variables that I have. Okay. So the example which Anand is quoting, it's very rare. Okay. But yes, if it happens in that way, then also we can do a correlation.
Yeah.
So correlation test can be done on multiple ways. You can use HT versus hold. You can do HT versus sales. You can do HT versus length. You can do these tests n number of times. So you have one continuous Y, and you can have multiple X continuous also. So that's how you'll be able to do it. Is it audible to? Is it clear to all of you? Are we
Yeah.
good?
Simar,
And
a couple of questions. So let's take the example of a correlation R value of 0.89. Can we say that there is a one-to-one match between hold and AST? So if I reduce the hold time to half, we can expect a 50% decrease in AST time?
Okay, so that is something which we will learn in the regression. So in regression, I'm just spilling the beans. In regression, we get an equation, okay, which would tell me, which also talk about that there are two different variables, but that tells me that how much I need to work upon on the hold to improve my average handling time. So that gives me another sort of a layer. So that is something, that's why in Y continuous and X continuous, there is a prerequisite to do both tests. Correlation will tell me the relation, and regression will tell me the sort of a equation that how much do I need to work on that to get to that level. So that is something which we will learn in the regression test. We will answer that question in the regression test.
All right.
Okay.
And
But
a
any
scenario, yeah,
yes,
sorry.
yes, please. No, you
Yes,
said you a couple of questions. So yeah,
yeah.
please go ahead for the
The
moment.
scenario two, we are showing in the R test, we are having a R value of, let's say, again 0.9. Okay. But the P value is less than 0.05.
Okay.
Then,
So yeah, so I'll answer this question. So what he's asking is my p value is showing null hypothesis, and my r value is showing sort of a very positive sort of a correlation, just kind of 0.9. What do I do in that case? So this was a kind of a conflict which always happens. What should I look at? Because my p-value says that my x and y has no significant correlation, but my relationship is very high, and that's why to remove this sort of a conflict from Minitab newer versions, the p-value has been removed. It doesn't show a p-value there. It only shows an R value. So I'm using an old version. My My new version Minitab is not working at the moment, so I would have shown it to you. Probably I'll show it to you tomorrow. That thing that in the Minitab, I think from 18, you will not see the p value. You will not see the p value. You will only see the r value in correlation. You will not at all see the p value.
Yes, they're showing only R value.
Yeah, yeah. You will only. But if you want to try, anybody wants to try, you will not see the p value. It used to be shown in the older versions, but because of a conflict, this happens. They have removed it, which means we don't have to consider p value here. That's why I did not even discuss p value. I haven't discussed anything from a p value. I was keep on discussing the r value here. Is it clear to all of you? So in correlation, we only have to look at the r value. If you're going through the old versions, but new versions would not have the p value at all.
And Simar, it's the same value that you get which we used with the formula Corel, right?
Corel, yeah, absolutely. That's the same thing. So I just showed it to you in the scatter plot itself, but in scatter plot we never show it like that. But I just wanted to show you the significance. So it's, if you use the similar example and use the Corel formula, you will get the same R value.